Hello, beautiful people, and welcome. In this video, we're going to be talking about how to take a given polynomial function that has been graphed and writing an equation for it in factored form. Now, in this video, we're only going to be discussing factored form. As always, if I make a mistake, let me know so that way we both can learn from my own mistakes. But before we write the equation, I wanted to briefly go over the things we need to take a polynomial function in factored form and graph it. So we're going to do one example on graphing a polynomial function. So let's do an example. For this example, I have 2 times x plus 3 times x plus 2 times x minus 4. And that's our polynomial function, so we have function notation. And for our exponents, we're not going to do anything too clever. We're going to have a 2 here. We're going to have a 3 there. All right, let's do this. I'm also going to give you steps because I feel that with them, it makes a little bit more sense. Step number 1, you want to identify the total degree of the function. Let's see if I can write. Now, the total degree of the function in a factored form is taking all exponents, seen and unseen, and add. So in this case, this is unseen. There's a 1 in there. Step number 2, you're going to identify the leading coefficient, or the number out in front. Step number 3, you're going to identify the end behavior of your function. Step number 4, you're going to identify your zeros or your x-intercepts. And step number 5, we're going to find the behavior at each zero. Okay, so let's go ahead, and now that we have our steps, if you want to write them down, go ahead and pause the video and quickly jot them down. But we're going to go ahead and continue. Step number 1, total degree of the function. So total degree of the function, we have 3, 4, 5, 6. 6 is even. Then we want the leading coefficient. Leading coefficient is 2. 2 is positive. So we're using our leading coefficient test to determine the end behavior. So we're looking at a total degree if it's even or odd. Where for leading coefficient, we're looking if it's positive or negative. Use that cheat sheet. If you haven't already taken that out, take that out. If you don't know what I'm talking about, go and watch the video on the leading coefficient graphic organizer. All right, so leading coefficient, our total degree. Next step we have is our end behavior. Now, you can go really fancy with end behavior, or you can go very basic. I'm going to show you the difference. So end behavior, since we have an even function that is positive, even means both the left-hand side and the right-hand side, they're doing the same. So I'm either going up and up or I'm going down and down. Because my leading coefficient is positive, that means I have an increasing function, so both of them are going to go up and up. So this is the basic version. My right hand is going up, my left hand is going up. Now, what that really means, it's not just arrows. What that really means is that when x approaches infinity, y approaches infinity as well. So as x gets really, really big, y gets really, really big to the positives. And as x approaches negatives, y continues to go up. So this is the fancy end behavior. This is the basic end behavior. So then we have 1, 2, 3. Now we need to identify our zeros. This is the fun part, in my opinion. Take every x that you see, any x minus this one because that doesn't include in our function. Take every x that you see, there it is, and you're going to ask yourself the question, what does this bubble have to be? Let me rephrase that. What does this x have to be for the bubble to be 0? What does this x have to be for the bubble to be 0? So for step number 4, what we're doing is we're going to, in our mind, take all of our x values, just the bubbles, and set them equal to 0 and solve. Now, I personally think this is a complete waste of time. I can just ask myself a question. So if I have x plus 3, what does x have to be for the bubble to be 0? And that's the same thing as saying, hey, I'm going to subtract by 3 both sides, cross them out, then x is equal to minus 3. I can do that without having to do all of the steps. If you need this step, go ahead. Just make sure, even if there's just one x without a bubble, there's a bubble. Mathematicians are lazy. We just don't want to put one there. So what does x have to be in order for the bubble to be 0? I need a negative 2 here. What does x have to be in order for this bubble to be 0? And that is positive 4. Now, what does this represent? This represents our x-intercepts. Okay, these are our x-intercepts. That means I have a point here, I have a point here, and I have a point here. So we have now identified our x-intercepts. Now we need to identify the behavior of those zeros. Now the behavior of those zeros comes from our exponent of the bubble. So since this is an exponent of 3, that means we're going to have a John Travolta. If we're going to have an exponent of 2, that means I have a parabola. So I'm going to kiss the graph. I'm not going to cross it. If you don't know what John Travolta is, go back and watch the previous video. We have Mr. John Travolta dancing. And then for this one here, we have 1. 1 is linear. So we're going to have a line. And so there you're pretty much done. That's it. Now you're left with just graphing. Again, when you're graphing, only mark up your x. Don't mark up your y's, because we don't know what's happening on our y's. You can find your y-intercept. If they're asking for your y-intercept, do it. If not, don't worry about it. All right. Here are your x-intercepts. You're going to mark them. So negative 3, 0, negative 2, 0, and positive 4, 0. Now, you can only have these intercepts. So basically, you can't do anything else. These are the only intercepts that you have. There's nothing else that you have. Plot the points, then identify the behavior. Behavior to my right, I'm going up, and to my left, I'm going up. I would highly recommend using a pencil at this point, so that's what I'm going to switch over. Hopefully, you guys can still see it. Okay, now that we have here, well, let's identify the behavior. For my negative 3 point, I'm going to have a line. A line means we go through. For my negative 2 point, I'm going to have a parabola. That means I'm going to kiss it. Now, I'm attaching it to my end behavior because I know from my end behavior, I'm going to go through my x-intercept, and somehow I'm going to have to get back up here, but I'm not going to cross because I have a parabola, so I'm going to kiss it. Do you see how if I cover this up, this is a parabola that's going downhill, parabola that's going down, and then there's parabolas that go up. In this case, we have a parabola going down. Now we have a parabola going down, so somewhere here is our y-intercept. Again, we're crossing the y-axis because I need to get my tush back up here somehow, right? So what do we have here? John Travolta. John Travolta is Mr. Let's see if I can draw this better. Mr. Curve. So we have a curve here. Now the curve needs to happen through that y. So you can't through that x. So you here, if this is your x-intercept, you can't go through it and then have a curve. You can't do that. And you can't see that either. So you can't go through it and then have a curve. That curve needs to happen at the x-intercept. All right, so that's pretty much it. You're done. And that's how you graph a polynomial function in a factored form. Now, that's not what this video is for. This video is for writing the equations. So let's go ahead and quickly do that. I'm going to give you your steps. There's 4 steps to writing these out. And you know what, you guys? I'm actually going to pause it. No, I'm not going to pause it. I'm going to write out your steps, give you an example, and then on a different video, we'll do more examples together. All right, so this is writing an equation. Again, this is in factored form. We're going to deal with expansions later. In factored form, what do we have? Step number 1, kind of working backwards. So step number 1 is identify the x-intercepts. These x-intercepts are the opposite of what goes into your bubble. For example, if your x-intercept is -4, 0, inside your bubble, you're going to write x plus 4, okay? Because x is the x-intercept. This is where the -4 comes from, but since we're working backwards, you're going to, in your bubble, do the opposite. So that's step number 1, identify your x-intercepts. Step number 2, examine the end behavior. So what's happening on the right-hand side? What's happening on the left-hand side? Again, if it is odd, the right-hand and left-hand side will be different. And if it's even, you're going to have your right-hand and left-hand side same. Now, the leading coefficient tells you if it's going to be up or down, if it's going to be an increasing function or a decreasing function. Okay, now that we have our end behavior, step number 3, find the polynomial of least degree containing all factors. So find the polynomial of least degree. So what that means is you're not going to find something with a 7 on your exponent. So when you have your exponents, you're going to stick with 1, 2, and 3. Okay, those are the exponents you're going to stick with. Yes, you can have a John Travolta with a degree of 9. We're not going to do that. We're going to try to write an equation with the least degree. We are not computers. We're just going to generate what the basic is. Step number 4, use any other point on the graph. I recommend using the y-intercept just because it has a 0 to determine the a. Now, a lot of times what they're going to say is, hey, assume a is 1 or -1, but sometimes they're going to be like, find a. So just like we were finding a in graphing cubic functions or writing the a from the graph for a cubic function, we're going to do the same thing. Pick a point, any point. I recommend the y-intercept. Plug it in, solve for a. Again, a is your leading coefficient, so you need to make sure you have the correct either positive or negative. Let's do an example right now. All right, beautiful people, let's do this example. Let me see if I can make it clear for you. We're going to try to follow steps. I may add a few other ones in those 4 that I gave you. So step number 1 is identifying your x-intercept. So I have a point here, I have a point here, and I have a point here. So my x-intercept, so you can say here are my zeros, but they truly are your x-intercept. So you have an x-intercept at -1, 0. You have an x-intercept at 2, 0, and you have an x-intercept at 4, 0. Now these here, you're going to identify your behaviors, or what you can do is, here's your x-intercepts, here's the opposite of them. Let me try to find a different color. And we're going to go on opposite inside the bubble. So x-intercepts, you're going opposite inside the bubble. And then after that, you're going to identify the behavior at each 0. For the x, so the behavior at each 0, that is your exponent. And your options are 1, 2, and 3 for your exponents. Okay, so let's see if we can figure this out together. So for my first x-intercept, I have -1 and 0. That means my opposite is x plus 1. If I have 2, 0, my opposite is x minus 2. If I have 4, 0, my opposite is x minus 4. Okay, so that's my opposite. Now I need to know what behaviors are at each 0. So at the x minus 1 intercept, what am I doing? I have a parabola. That means I'm kissing the x-axis. I'm not actually following through. I'm not going through it. So that means I have an even exponent, and my exponent is 2. At 2, 0, I have a curve. It's going down and then it's going up. It's a curve. So from a curve, we have Mr. John T, which means we have an odd number, and it's not 1 because 1 is linear. So we have an exponent of 3. Now at 4, we notice that it goes right through 4 as a straight line. So this is linear. And so we have exponent of 1. Okay, so how do we write the actual equation? So far, we have outside the bubble. Take your outside the bubbles, and you're just going to write them as multiplication. So you have x plus 1, x minus 2, x minus 4. You're then taking the exponents that you have identified and placing it on the correct bubble. So this is 2, this is 3, this is 1. Now, you're not quite done. So let's see here. We got to check end behavior. So my end behavior are down and down, which means I'm going to have an even total degree of the function, because left and right-hand side are both the same. And it's going to have to be a negative a because it's decreasing, going down. So what is my total degree of the function? 2, 3. So this is 3, 4, 5, 6. So n is 6. N represents your total degree of the function, which is 6, which is good. So it should be even because both of them are the same. Now we need to solve for a. Now how do we do that again? Well, we have this f of x. F of x is really y. So we have y, then we have a. I'm going to write everything else out here real quick. And we have our x's. So I'm going to take my y-intercept, and y-intercept is negative 4, 0. So that means, just kidding, it's 0, negative 4. That means my x values are 0 and my y value is negative 4. So my y value is negative 4. A, we don't know, so we keep a. And for all of my x values, I'm going to write 0. And you're going to solve. You're going to solve for a. Now, we know that a is going to be negative because they're pointing down. Anything that's decreasing has a negative a value. So what is this? 1 squared is 1. Let's see, negative 4 times a, this is 1. Negative 2 times 2, that's 4. 4 times 2, that's 8. So I have a negative 8. Negative 4 to the first power, that's just negative 4. So I have negative 4 is equal to a times 1. So 1 goes away. 8 times 4 is 34. 2 negatives make a positive. I'm going to divide by 32. I said 34, didn't I? 32. Divide by 32. A is equal to negative 4 divided by 32. Again, right now, my main concern is that it's negative 4 divided by 32. What is that? Didn't I just say that? Isn't it 8? It's 8. So we have an a value of negative 8. Oh, we don't. It's 1/8. Silly me. It's 1/8. Doesn't matter that this is a fraction. We don't care that it's a fraction. What we care about is that negative symbol. So what is my final answer for this graph? My final answer is f of x is equal to negative 1/8 times x plus 1 squared times x plus 2 cubed times x minus 4. Now, if you give me this answer, fine. However, it is incorrect format. So what you need to do is you need to order the exponents from least to greatest or greatest to least. So in this case, you can do negative 1/8 x plus 2 cubed, x plus 1 squared, and then we have x minus 4 to the first power. I am not picky about this. I don't care. My main concern is, do you actually have all the bubbles correct? Did you do the opposite of every intercept? Are your exponents correct? And is your a value plus or minus and the correct value? That's what my main concern is. All right, beautiful people, this video is now becoming a little bit on the longer side. I'm going to do a separate video on more examples, how to write your equations in factored form for polynomial functions. Thank you for watching.